Okay, here you have two special right triangles, and today in this video we're going to derive the relationship between the sides in these two right triangles. The first right triangle is a 45, 45, 90 triangle. Notice these are in reference to the angles in the right triangle. Because there are two angles that are congruent, we know automatically that then this is an isosceles right triangle. If we want to find the relationship between the sides, we can use Pythagorean theorem to do that because we already know that because it's an isosceles triangle, these two sides are also congruent because the sides opposite. There are the sides opposite to the angles that are congruent. And if we want to know something about the hypotenuse, which in this case we'll call h just for hypotenuse, we can solve for the hypotenuse in the right triangle by using Pythagorean theorem to see how it relates to the legs, x. So Pythagorean theorem, a squared plus b squared equals c squared, helps you to find a side of a right triangle when two sides are given. And here we know two sides are x, so x squared plus x squared equals h squared. And then we are looking to solve for h to see if we can see the relationship between h and x. So we continue by combining these, simplifying the left side, and we get 2x squared equals h squared. And again, we're solving for h. From there, we can square root. And in the algebra, it would be plus or minus, but we know that x is definitely a positive number because it's distance of a side. So we can skip putting the plus or minus there. We can assume that this is going to be a positive square made by a positive x. So if we continue in this path here, we get h alone, which is what we wanted. And this is going to be, I'm going to do this on the side here, square root of 2 times x. And I do this prime factorization so that I can simplify by square rooting the x squared. So the square root of x squared is just x. And then what didn't get square rooted is the 2. So I leave that under the radical. So I have h is equal to x times the square root of 2. And now I know that the hypotenuse, which is h, is larger than x by the factor of times square root of 2, by the factor of square root of 2. So the hypotenuse is square root of 2 times either one of the legs. Here in this triangle, this is not a 30-60 triangle, 30-60-90 triangle yet, but if we were to make this an equilateral triangle where all the angles are 60 degrees, and we drew a hypotenuse, or an altitude from one vertex to the opposite side, that would create a 30-60-90 triangle. So because of the symmetry that altitude is splitting this triangle into two congruent triangles. So if we were to identify each side of this equilateral triangle as 2x, then we can focus on just this yellow triangle, which is the 30-60-90 triangle. That would be x, because that 2x is divided evenly into two congruent triangles. So now at this point, we know that the hypotenuse is 2 times as big as that short leg opposite from 30. So we're left to find this altitude here, this this one right here. So let's call it A for altitude. Okay, so we're looking for that long leg. That's the long leg because it's opposite from 60 rather than 30. Okay, so let's focus on this triangle, and if we want, we can pull it out there so that we can focus on just that 30, 60, 90 triangle. Okay, remember I called each side in the equilateral triangle 2x, and when I drew the altitude, I got x here opposite from 30. And now I'm looking to solve for this long leg. Okay, and then I'm calling that A. Okay, so I can use Pythagorean theorem here, and it just so happens that A represents a leg in the Pythagorean theorem, so it'll be nice when we enter A there. It won't cause a problem. So we have the Pythagorean theorem, which is A squared plus B squared equals C squared, the hypotenuse squared. A and B are the legs, and so the legs in this case will be A and X in this particular example. So A squared plus X squared, and then our hypotenuse is 2X squared. Okay, so everything from this particular example is entered in the second line here. And so we need to look back and see, okay, what is it we're trying to know? We're trying to know this long leg. So we're going to solve for A and figure out how it compares to X. So let's simplify the right side here. We get 2X times 2X. That's going to be 4X squared. So I can put 4X squared here. And then A squared plus X squared. From there I can subtract X squared, because remember I'm trying to get A alone, and before I do that I have to get A squared alone. So now I have 4X squared minus 1X squared, which is 3X squared. And then I'm going to square root to undo the square. And I get A is equal to, well, let's do this on the side like I did last time. 3 times X times X. Here's a perfect square. I can square root really easily. So the square root of X squared is just X. And what got left inside that did not get square rooted is that 3. So A, which is the long leg, is equal to square root of 3 times X, or X times the square root of 3. What this tells us is that the long leg is that much bigger than X, square root of 3 times as large as X, the short leg. So the long leg is square root of 3 times the short leg, and the hypotenuse is 2 times the short leg, as we established earlier when I made this equilateral triangle with all sides equal to 2x. So from there, we get these side ratios for the 30, 60, 90 triangle, which is n for the short leg, n times square root of 3 for the long leg, and 2n. So in this case, n represents the short leg. Okay. In our particular example, it was x to x times the square root of 3 to 2 times x. But the ratios are still the same, as you can see by the factors. Okay, and in this case, the 45, 45, 90, the legs are the same, and the hypotenuse is square root of 2 times the either leg. Okay, so it doesn't matter what variable you use to call the short leg or the leg here in the 45, 45, 90 triangle. You just need to know that these are the factors that are grown from those short legs. Okay, so these are the important factors that you need to know. Oops. Okay, in the next video, we will take a look at how we can